Okay, the next question that we'll attempt to answer is how long will it take your money to double if the interest rate is 9% compounded quarterly and then compounded continuously? So it says how long will it take your money to double? Well, it doesn't tell us how much money we have, and so we will just use a placeholder. Let's just use lowercase p to represent how much money we have, and it says that at an interest rate of 9%, so the interest rate R is equals to 9%. And the question is how long, so T is unknown. Well, since we're doubling our money, the amount we will have in the end will be 2 times P, and hopefully that will be enough to get us to our answer. Well, let's set the equation up. The overall formula is A is equals to P times 1 plus R. Oh, that's compounded quarterly, sorry. So N is equals to 4. 1 plus R over N raised to the NT. And so in this case, this is going to be 2P is equals to P times 1 plus 0.09 divided by 4 raised to the 14. Now, although they didn't tell us how much money we have, in the very first step of the problem, when we divide by P, we realize that it actually does not matter how much money you have. The time it takes to double is independent of how much you have. Now that I have this right here, I realize that this is an exponent, and to get to the exponent, I have to take the right logarithm, and so I'm going to take ln on both sides of the equation. So ln of 2 is equals to ln of 1 plus 0.09 over 4 raised to the 4t. With that being said, right there, with that being said, I can then bring the 4t down. I can bring the 4t down, and so that will be ln of 2 is equals to 4t times ln of 1 plus 0.09 divided by 4. And then to go ahead and solve for t, I have to divide by everything that is not t. And so I will divide by 4 ln of 1 plus 0.09 over 4 on both sides of the equation. So the 4's cancels out. So that means that t is equals to ln 2 divided by this happiness and joy right here. And you plug that into your calculator, and it tells you that t is approximately 7.8 years. So if I had to do this and get interest payments every quarter, that's how long it will take my money to double. Interestingly enough, this is the reason why you want to be rich. Because if you have $5, it'll take you 7.8 years to double that $5 to 10. But if you had $5 million, in that 7.8 years, you would get another $5 million to get your money up to 10 million. And so the more money you have, the faster you make money. That's just how it is. So it's good to be rich. Now, with continuous compounding and the same problem, so how long will it take your money to double? So the principal is P. The interest rate R is 0.099%, and the amount at the end is going to be 2P. And again, we're looking for T. We don't need N when you're compounding continuously, because technically N is infinity. And so with this right here, we set up our equation. A is equals to PERT, P-E-R-T. And so once you have that right here, you can go ahead and write your 2P or not 2P. I just was tempted. 0.09 multiplied by T. And then, of course, I first start by dividing out the P's. And again, we see that the amount of money you have does not dictate the time it takes to double that money. Got an E. To cancel the E, I take an ln. And of course, we had that special relationship between E and ln. And that E and ln cancel each other out. And so all I'm left with on the right side is 0.09t. So of course, all I have to divide by is 0.09. And so that tells me that the time is equal to ln of 2 divided by 0.09, which is 7.7 years. So with continuous compounding, we save a whole 0.7 years, 0.1 year, which is, by the way, we don't see continuous compounding in normal business transactions. Most people don't understand what continuous compounding is and think that, well, if I'm always getting paid interest, aren't I immediately always super rich? And so instead, they use just about any other format they want because the numbers don't really change that much. Small difference when you're compounding continuously versus when you're compounding um, with any other rate. Okay, one more question. Okay, so at what rate do you need your money to grow? So at what rate do you need your money to grow if you have $5,000 but you need $8,000 in 10 years? Let's say you try and buy a car and you know that a few years down the line you want to spend $8,000 on that car. All you have right now is $5,000. So you guys, well, I'm willing to wait because I already have a car right now, and this is going to be my car buying money. So, well, how do I need to invest my money? Where do I need to put my money to get there? And we're going to have continuous compounding right here. All right. And so with that right here, I set up my formula. A equals to PERT, P-E-R-T. I need $8,000. I start with $5,000. E, the interest rate is unknown, but I know I want to get there in 10 years. I divide by 5,000. That does not look like a 5. I divide by 5,000. And so what I have is 8/5 is equals to e to the 10r. And of course, we know there's a special relationship between ln and e. So I take ln on both sides. And so I get then that ln of 8/5 is equals to 10r. Of course, I then divide by 10. And that tells me the interest rate is going to be 0.047 approximately, or 4.7%, which is not a bad rate when looking at therefore rates of growth that you'll need to get there. And so hopefully you can get there, buy your car, and not actually have to go into debt at all. Have a nice day.